You're good. Let us look at polynomials. Polynomials are algebraic terms which consist of two or more terms inside. So a polynomial is given by f of x is equals to a sub n x to the power n plus a sub n minus 1 x to the power n minus 1 plus a sub n minus 2 x to the power n minus 2 plus a sub n minus 3 a sub n minus 3 x to the power n minus 3 plus a sub n minus 4 x to the power n minus 4 plus so on. These are the characteristics of a polynomial. A sub n or a sub n minus 1 or a sub n minus 4 is any constant that you'll have in a polynomial. And n minus 1, n minus 2, n minus 3, which and n minus 4 which are exponents. What do I mean by exponents? All about that. These values of n, those values of n minus 2, n minus 3, n minus 4, those are exponents which are positive real numbers. Let me just remove this part of real whole numbers. These are positive real whole numbers, which means those values of n which you see there can never be fractions or negative. Understand? They can never be fractions or negative. Let us look at an example. What is a polynomial or not? Let me just give you y is equals to 2x cubed minus 4x squared minus 5x plus 1. Y is equals to 1 over 2x to the power 0.5 minus 1 over 2 root x minus 1. Now, which one here is a polynomial? Which one here is an algebraic expression? This one is a polynomial. This one is an algebraic expression. Let me just say this is A, this is B. A, it's a polynomial. And then B is just an algebraic expression that you just find anywhere, right? It describes anything. Why do I say that A is a polynomial? Look at the exponent of y, of expression A. These are whole numbers, and they are written in a decreasing powers of x. What do I mean by that? Written in a decreasing power of x. If this one was x to the power of 4, this one should be x to the power 3, this one should be x to the power 2, and so on. Since this one is x to the power 3, the next one is x to the power 2, the next one is x to the power 1, the next one was x to the power of 0, because 1 can also be written as x to the power of what? Of 0. This one has an exponent, which is a fraction or a decimal. This one has an x, which is in the denominator. So this expression here can never be a polynomial. Can never be a polynomial. A polynomial can be expressed like that. A polynomial does not care about how many times that it consists, as long as the powers of x are positive and they are not fractions. That is a polynomial, right? Very, very simple. Now let us first look at the two theorems that you actually are going to learn. The two theorems. The two theorems. Right, the first one is called the remainder theorem. The remainder theorem. And the second one is called the factor theorem. The factor theorem, very, very, very simple. Very, very, very simple. Trust me. Very, very simple. So, how do you understand, or how does one understand these theorems? I'm just going to explain a lot of theory here. The first one, let me just call this one A and then call this one B. A, which is called the remainder theorem. A theorem. Remainder theorem. A remainder theorem, guys, very, very easy. You can even tell by the name of the theorem. It means that in a given polynomial f of x, there is a chosen factor. That factor, I'm just going to call it a of x plus b. A of x plus b. Understand? In a given polynomial f of x, there is a chosen factor which is ax plus b. Finding the zero of the factor gives x is equals to minus b over a, and subbing to f of x result in f of negative b over a is equals to r. What does this statement mean? It means if you find the zero of this, what does it mean to find the zero of that? To find the zero of that, if you want to find the zero of ax plus b, you need to equate this to 0. And what makes this equals to 0? X is equal to negative b over a, which means you need to solve for x here. Now, taking this and substituting to a particular polynomial, which is f of x, the moment you substitute something, you will have a remainder. That is the remainder theorem. It states that any factor that you get, the factor equated to 0 and substituting something that makes the factor 0 to a polynomial will give you a remainder. Remember, a remainder can never equals to 0. A remainder is positive counting numbers or negative counting numbers. Right. Let us look at the question here. Find the remainder of f of x is equals to x cubed minus 2x squared plus 1 if the chosen factor is 2x minus 3 and x minus 2. What is the remainder of this? What is the remainder? So we have this factor and we have that factor. The first thing that you need to find the zero of this factor. What do I mean by finding the zero of that factor? Take that factor and equate it to 0 and then solve for x here. X is equals to 3 over 2. And then take this 3 over 2 and substitute it to f of x. So I'm going to have f of 3 over 2 is equals to, where do you see x? You are going to substitute 3 over 2. So I'm going to have a 3 over 2 cubed minus 2 times 3 over 2 squared plus 1. Punch in your calculator, you will have a remainder. Minus 2 times 3 over 2 all squared plus 1. The answer is going to negative 1 over 8. So the remainder of this f of x, when the factor is 2x minus 3, is going to be what? Minus 1 over 8. Now let us find the remainder of this expression when the factor is x minus 2. So we need to take the factor and find the zeros of that factor, which is x minus 2, right? X minus 2, and then equate it to what? To 0. And then so for x is equals to a plus 2. Take this and substitute it to f of x. So where you see an x, you substitute it to. And then solve. Punch that in your calculator. You're going to have a 1. Right. So this is the other way you can find a factor. This is another way you can find a factor. Understand? This is the remainder theorem, guys. I don't think there is anyone who will have a problem dealing with the remainder theorem. Let's look at the second one. A second problem says, number 2, find the value of k if 2x cubed minus 2kx squared minus 4 is divided by x plus 1 and the remainder is 4. What will be the value of k? What will be the value of k? What is the value of k really? So the question you need to understand, it says find the value of k if 2x cubed minus 2kx squared minus 4 is divided by x plus 1 and the remainder is equals to 4. That thing means when you find the 0 of x plus 1, solving for x here, x is equals to negative 1, which means if you substitute a negative 1 to the expression, the answer that you need to have is equals to what? To 4. So let us do that. So you're going to have 2 times x cubed minus 2kx squared minus 4. Substituting this 1 here, the remainder that you're going to have what? 4. So I'm going to have 2 times 1 cubed minus 2k times 1 squared minus 4 is equal to what? To positive 4. And then you need to solve for k. This is 2, and then going to the other side, I'm going to have negative 2k, which is 4 plus 4 minus 2 is going to be 6. And then divide both sides by negative 2, k is equals to what? Minus 3. So your value of k here, when substituting negative 1, is going to be negative 3. Because if you divide by this factor, the expression, kuno positive 6 lapan, you are going to get what? 4. Let us try it. So you have 2x cubed, if we substitute a k lapan, I'm going to have positive 6x squared minus 4. Let us substitute to negative 1 cubed lapan. No, it's not. It's going to be plus 8. Sorry, guys. It's going to be plus 8. It's going to be plus 8. What do I say? It's plus 8. Since there is a negative 1 here, this is going to be negative 2. Outside, there is going to be 8. And then k is going to be what? K is going to be negative 4, if I'm not mistaken. So, negative 4 times that is going to be that. So it's going to be 2x cubed plus 8x squared minus 4. If you substitute a lower and left, not all negative 4, so negative 1 cubed plus 8 times negative 1 squared minus 4. Now you can really see this is negative 2, that is negative 4. So it's going to be negative 2 plus 8 minus 4. Your answer is going to be 2. Mana. It's going to be negative 4. It's going to be 4 plus 4 plus 2, which is 10. Oh, Lord. It's 10. And then divided by negative 5. Shit. How many times do I need to rub? So there it's going to be negative 5, so it's going to be positive 10. Positive 10. If you substitute positive 10 there, you are going to get, if you substitute positive 10 there, you are going to get positive 4. You are going to get positive 4. A quick summary on this, it says, find the value of k if 2x cubed minus 2kx squared minus 4 is divided by x plus 1 and the remainder is 4. It means that if you find the zeros of x plus 1, and substitute the 0 of x plus 1 to this expression, your answer that you're going to get is going to be what? It's going to be 4. You understand? So I think you need to understand that. Now, understanding this concept of a remainder when I was in high school, I always ask myself, if you have a remainder, which means you are short with numbers to get to the final answer. You understand that? So if you say 5 divided by 2, what is 5 going to be divided by? 5 is going to be what? 5 divided by 2 is going to be 2.5, which means the remainder there, r, is going to be 0.5. It's not really 0.5. It's going to be 1. It's going to be 1. Why I'm saying 1? It is because 2 times 2 is going to be 4, and 2 times 0.5 is going to be 1. So the remainder of this is going to be 1. Because if you say 2 plus 2 times, if you say 2 times 2 plus 1, you're going to get what? 5, which means 2 goes 2 times to 5, and there's still a remainder of 1 to give you 5. And how do we get these 2? How do you get something that will give us? How do you get something that if you add it with the remainder, it's going to give us 5? So there is this thing that you need to know. If you take a particular function of f of x and divide it with something of q of x, what really is going to happen? You are going to have a function of k of x plus a remainder r of x divided by q of x. So this is the remainder. This function, it's what goes to f of x qx times. You understand? It what goes to f of x qx times. So if you have 5 over 2, which means a 2 goes to, how many times does 2 goes to 5? 2 times, plus 1 over 2. If you have this 4, 5 over 2 is equals to 2 plus 1 over 2. Remember, this one was a remainder, and this 2 is your q of x. This 2 there is still your q of x, and this 2 here is your k of x. How many times it enters to that point? Right. Let us use, to find this thing here, we need to use something called the long. We are going to use something called the long division. Right. We are going to use something called the long division. So, what is the setup of the long division? Very, very simple. What stays here, it's q of x. What stays here, it must be f of x. And you continue until you have r of x there, and then here you're going to have k of x. A setup of the long division is like this. You are going to have your q of x there, you are going to have your f of x there, you are going to have your r of x there, which is your remainder, and you are going to have your k of x over there. Understand? So here you can take something here and write it in that form. It does not matter. Now let us divide something. Now let us divide this expression here. I'm not going to use that expression now. Divide x cubed minus 2x squared minus 3x plus 1 by x minus 2. X minus 2. What can you do? How can you divide that? We are going to use long division. At most cases, we are going to use the long division. So you need to take note. So this is going to be what? Your f of x. This is going to be what? Your q of x. Just remember, guys, we use different notation to represent this. Some books can represent this as your q of x, this part here. Some books can represent this whole part here as q of x and this part here as p of x. It does not matter, but you need to know your strategy and how you can write it in this form. It does not matter how we write it. So we need to write this as in a long division form. So I'm going to have x cubed minus 2x squared minus 3x plus 1. And then here, I'm going to write x minus 2. Please listen and listen carefully. How do you divide using long division? It's a very easy process, but make sure you listen. Right. To use long division or to divide by long division, we only use one thing. Since this is a linear factor, to divide this expression by this factor, we only use x pen. We do not use the whole thing of x minus 2. We use x only. We do not use a constant of minus 2. We use x only. So this is going to happen. How many times does this x goes to x cubed? You ask yourself that. How many times does this x go to x cubed? So you are asking, what is x cubed divided by x really? What is x cubed divided by x? That is going to be x squared. So how many times does x go to x cubed? X squared times. And then, if you have that x squared there, take this x squared and multiply it to x and also to 2. So I'm going to have x squared times x, and then I'm going to have x cubed. x squared times negative 2, I'm going to have negative 2x squared. If you are done doing that, put bracket over there and put a negative sign in front and close off this transaction. Understand? And then to simplify here, I'm going to say x cubed minus x cubed is going to be 0. Minus 2x minus 2x. Just put your calculator. Minus 2x minus 2. Your answer is going to be 0. So it's going to be what? It's going to be 0. And then bring down negative 3x. Ask yourself again, how many times does this x goes to negative 3x? Negative 3 times. 3 times that, it's going to be what? It's going to be negative 3x times negative 3 times that is going to be what? Plus 6 times. Put bracket over there and then in front substitute a negative and then divide. Or you need to bring down plus 1 there. And then you need to say negative 3x minus 3x. I think that is going to be 0. And say 1 minus 6. 1 minus 6 is going to be what? Minus 5. And then you ask yourself again, how many times does this x goes to negative 5? Since there is no x variable here, this becomes your remainder. And then that becomes your k of x. Right, so what you can actually do, now you can just say x cubed minus 2x squared minus 3x plus 1 divided by x minus 2 is equal to what? X squared minus 3 minus 5 over x minus 2. This is done deal. Now, how can you check this is a remainder, correct remainder? Put positive 2 here. If you say 2 cubed minus 2 times 2 squared minus 3 times 2 plus 1, your answer is going to be negative 5. 8 minus 2 times 4 minus 6 plus 1, your answer is going to be negative 5 here. So the remainder is correct, right? Let us look at another problem when using the long division. The question will be, write 4x cubed minus 7x squared minus 2x plus 1 divided by x minus 2, right, in a form of f of x over p of x is equal to z of x plus r of x divided by p of x. Which means if Betty writes this thing in this form, what you can actually do, you need to do a long division la and then write this thing in this form. Very, very easy. Do not panic. So, using our long division, so I'm going to have x minus 2 here. I have a 4x cubed minus 7x squared minus 2x plus 1. Like that. And then how do I divide this with our long division? I'm repeating this again. To divide this thing using long division, we do not use this whole term. We do not do that. We only use this value of x there and divide everything across. So we ask ourselves, how many times does x goes to 4x cubed? It's going to be 4x squared. If you are done doing so, take this 4x squared and multiply it to 4x and 2. So I am going to have what? 4x cubed minus 8x squared. Put brackets over there and say minus over. 4x cubed minus 4x cubed is going to be 0. Put a dot and say negative 7 minus 8 is going to be what? X squared. Bring down minus 2x, right? And then ask yourself again, how many times does this x goes to x squared? Very, very simple. Positive x times. Take this value of x, multiply it to x. I'm going to have x squared. Take the same value of x and multiply it to negative 2. I'm going to have negative 2x. Like that. Say it's minus, like that. Minus. And then ask yourself, x squared minus x squared, that is 0, minus 2x minus 2x, that is 0. Bring down that value of 1 plus 1. How many times does this goes to 1? There is no variable of x learning it, so this becomes your r of x. So writing this in remainder form, I'm going to say it's going to be 4x cubed minus 7x squared minus 21x plus 1 divided by x minus 2 is equals to, your z of x is going to be 4x squared plus x, plus your r of x is going to be 1 over x minus 2. X minus 2. Right. Now, f of x all over p of x is equal to z of x is equals to r of x. You can actually manipulate this equation. How can you manipulate it? You can take this x and multiply it across here. So f of x is equals to z of x times p of x plus r of x, which is really true. If you bring that equation that we had the last time, which is 5 over 2 is equal to 2 plus 1 over 2. This thing is true, really. This thing is true. Because if you can take this 2 and multiply it there, you can see that 5 is equal to 2 times 2 plus 1 over 2 times 2, which is 5 is equal to 4 plus 1, which is 5 is equal to what? To 5. This equation here is the same as that equation there. I think this will make sense on the remainder theorem. Right? Thank you so much.